Well, we got another test here. This is number 3, and I got a few shop stories to go with it. Some you may have heard before, some you may not have, I don't know. A7 practice test number 3, HVAC, and some more shop stories. Question 1, which component is responsible for converting the high pressure liquid refrigerant into a low pressure mist? The compressor, the receiver dryer or accumulator, the thermostatic expansion valve, the condenser fan motor assembly. Which of those? It's going to be obviously the thermostatic expansion valve, and that's not unlike a fixed orifice. This is basically a variable orifice, and so this is what you're looking at here coming from the condenser. Let me turn on my laser here. You got your liquid coming through here. It mists through this little orifice, which can be will move based on the temperature of the air coming through here, and or if it's got one of those with a remote bulb connected to this little chamber, it basically lets that, it throttles this so that it won't freeze the evaporator. We've talked about this before. Not a bad idea to burn this stuff in. So from the condenser to the compressor, and what's coming out of here is low pressure gas. Okay, that's question 2. Blower motor only operates on the highest speed setting. What's the most likely electrical failure? Would it be an open blower motor ground, resistor thermal fuse, control head software glitch, or pitted contacts on the high blow relay? Well, on this particular schematic I showed you, the blower motor only operates on the highest speed setting, and the most likely electrical failure is the resistor thermal fuse open. And you notice even on the old blower motor resistors and on the new blower motor resistors, they all have some kind of a thermal fuse on them. And typically I would go to Radio Shack whenever I've experienced this, because I just enjoy doing it. If they didn't have a blower motor in stock, and it was, before lunch, let's say, and I'd zip off down to the mall to have lunch, and I'd go by Radio Shack, and for $1.50 I'd buy a thermal fuse. They had them at Radio Shack right there in the mall. Of course, Radio Shack's pretty much gone now. But I'd come back and I'd put me some dielectric grease and some alligator clips on here for heat sink to keep my soldering operation from opening the thermal fuse. And then I would clip out the old fuse, and I would solder in the new one. Incidentally, I don't know if you knew it or not, but welders know this. If something you're making it really hot down here, the heat won't travel around that corner to this other leg right here. You might see, if you see a professional welder using a torch and a piece of rod to weld, when he gets down there where his rod's not very long, he'll bend a 90-degree angle real sharp in that rod, and he'll hold it above that 90-degree angle, and the heat from that rod won't travel around the corner. I always thought that was very interesting, and I'm not sure exactly why, but I don't know how many times I've seen that, and I've actually tested that myself. But that thermal limiter is there in case something gets in there. Let's say that your blower motor is still pulling current, the fan's not turning because maybe there's airflow blocked or something like that, or maybe a bunch of cruds in it, and that thermal limiter on low blow, these resistors get really hot. And one time I was driving to Savannah, and I had left work and I was headed over to Savannah, and it was like middle of the afternoon, and I had to go over there. Anyway, I saw this Explorer sitting beside the road with the hood up and a bunch of yo-yos standing down in front of it, and this woman that looked like she was in distress standing there with them. And I pulled over and I said, "What happened here?" And she said, "Well, I was driving along and my passenger compartment right there filled up with smoke." And she says, and I don't know what's going on here, and so I stopped to open the hood and see what was happening, and these guys stopped to help me. And so I opened the driver's door and I stuck my head in there and I smelled the burning leaves. And I says, I bet you were running your blower on low speed, you know, because the switch was on low speed. And she said, well, yeah. And I said, okay, so what has happened is some leaves from you parking under trees has worked their way into the blower housing, and they came to rest on the blower resistor, and you need to get those leaves out of there. But you can drive this, but you either need to run the blower on high speed or turn it completely off. And that's all you need to do. See, these other guys were looking under the hood. You weren't going to find the problem looking under the hood. Her problem was actually in her blower plenum. And so she said, well, thanks, and she went on her way. But if that thermal fuse in the resistor block fails, it cuts off everything going through the resistor, and it will only work on high blow. Now there's, you might notice on the schematic I showed you that the blower relay on that particular one is feeding the blower with power all the time, and the ground is fed to it through the blower resistor, and that's not uncommon. Question 3, what's the result of a stuck blend door? All air to the defrost vents, the refrigerant won't flow, can't change air temperature, or the blower motor won't run. Well, this is basically you can't change air temperature. Now, all air to the defrost vents on one that has vacuum operated doors, it defaults to the defrost vents when you lose vacuum. So if you're heading up a hill and you're going into the throttle pretty deep, you're going to see you're going to feel the air go up to the defrost vents, and then when you come back on the level ground, it comes back out. That's basically usually either a leak in a vacuum line, or more commonly it'll be that one-way check valve feeding the vacuum reservoir, which sometimes the reservoir's got that check valve built into it. But anyway, this can't change air temperature is what the deal is, because when this moves over, all the air coming in here goes through the heater core. After being dried out by the evaporator and dehumidified, it goes through the heater core. When it's in the middle, you're going to have dry air going. This actually helps with your defrost too, because it defrosts the glass. If you've ever had an old car or one the AC doesn't work on, when you turn that thing on defrost, the compressor is supposed to kick on if you got AC anytime it's on defrost, even if you hadn't turned on the AC. Well, when you turn on defrost, the compressor kicks on, it dehumidifies the air, and the air that hits the glass is real dry, and that really helps out. Now, these right here, the outside air, whenever you still had this typically would be operated by a electric blend door actuator. Even on the ones that everything else was manual on, the blend door needs to be able to stop just anywhere. Now, they did have a 2-stage vacuum servo on some of the older ones that would stop it halfway and then let it go all the way. But the electric blend door actuator, since way back in the 90s, they've actually had a little motor with gears and all to drive this, and a potentiometer in there so that we get feedback to the control head or whatever. But if it needed feedback, some of the control heads don't even need feedback. Question 4, when testing a compressor clutch with an ohm meter, a reading of 1.8 ohms generally indicates A, a broken coil winding, B, a good magnetic clutch coil, C, a shorted clutch coil winding, or D, a poor clutch coil ground feed. Okay, watch this meter reading change here. When testing the compressor clutch, if you see 1.8 ohms, you got a shorted clutch coil winding. You're supposed to have between 3 and 5 ohms. A lot of the times we don't even think about how many ohms that thing is supposed to have. Typically these things, when they short out, they'll start popping fuses. This friend of mine has a shop. Somebody brought him a 2006 Impala that it would blow the fuse for the compressor clutch. And so he says, okay, so he investigated it. The compressor clutch was still working, but it was pulling too much current because it was only partially shorted. And so he told the guy, he says, we're going to need to replace that compressor clutch at the very least. Probably just should go ahead and put a whole compressor on it because it doesn't cost that much more. And so the guy, he says, bring it back Monday. Well, the vehicle didn't show up at his shop on Monday, and he just didn't think much about it. He just moved on to the next appointment and so on and so forth. And about a week later, after this guy, the guy showed up a week late, and he said that he had decided to go ahead and take a piece of Romex wire, take the fuse out, and bend that Romex wire into a U and shove it down where the fuse goes in the fuse panel. Because he said, well, I can keep this fuse from blowing. He got annoyed because it kept blowing and he wanted AC. And what he managed to do there, because the clutch coil was shorted, is it overheated the wires, burned everything up so that wires were wired together in the wire harness, and there was all kinds of other problems. And so my buddy told him, he says, look, they don't have a wire harness available for this anywhere. He couldn't find one at a salvage yard or anywhere else. Now, a lot of times if you get one from the salvage yard, they don't unplug any of the connectors, they just clip them off, you know, and it always irritated me to no end when I did get one from a salvage yard. But of course good salvage yards will unplug the connectors. Anyway, he says, I'm going to have to take the wire harness completely out from under the hood here, you know, the one that's affected, which basically the whole thing, and I'm going to have to split the tape off of it, and I'm going to have to fix every wire individually. And I can do that, but you're going to pay me my shop rate for as long as it takes me to do that, because I don't have a fixed rate for fixing a wire harness that's burned up like this, and especially since you can't just replace a wire harness. And that guy just drove away with an air conditioner that didn't work and a bunch of other problems that he had made for himself by bypassing the fuse, by pulling the fuse and putting a piece of 12 gauge Romex wire in there. Not only did he that, but he spread the fuse terminals on the fuse box. This guy, you know, thought, well, I'll just go ahead and fix this myself by, you know, taking the fuse out. Well, he found out why the fuse was in there. Okay, which sensor is primarily used to prevent the AC compressor from engaging in freezing ambient temperatures? Is it the ECT sensor, the MAF sensor, the AAT sensor, or the sun load sensor? Well, that's an interesting question, isn't it? This is going to be the ambient air temperature sensor that sends data to the HVAC module of the PCM to prevent it from running when outside air is too cold. Now, a lot of those algorithms we don't even know. This is basically the way it looks in the programming. Now, one of the things that I had experienced on a Ford Aerostar, if you remember any of those things, this thing would you drive down the road and the air conditioner would just, when it would cycle off for like, the air conditioner cooled really, really good. And whenever you would feel it cycle off, and it would do it driving down the road or sitting still, it would, and it had a belt-driven fan, by the way, it would cycle off for probably 4 or 5 minutes before it cycled back on. And so I measured what I had tendency to do in those days. We didn't have data stream on that particular year model of Aerostar. Ford didn't come out with data stream on any of their stuff for 1988, and it was on Continentals. Anyway, I back probed the engine coolant temperature sensor, and I noticed that thing had a skewed reading that it was sending the engine controller, and it was reading hotter than it should have been, but it wasn't completely open. You see what I'm saying? So I said, all right. So I noticed as the thing cycled off, the ECT sensor was telling the engine controller the engine was hotter than it actually was. And so in order to, the algorithm that nobody told us about, because there's not a book thick enough to write down all the strategies in there, you just learn them as you go. That engine coolant temperature sensor being skewed was making the PCM turn off the AC compressor until that ECT reading came back down below the threshold. I don't remember what the threshold was. And so basically it would turn off the AC until it was satisfied that the hot air coming through the condenser wasn't going to cause a bigger problem. The GM cars, back when they had the computer command and control feedback carburetors, what they would do if they detected an overheating engine was they would basically release the mixture control solenoid in the carburetor so it would be up all the way, and it would, because when it was energized it was down, when it was de-energized it was up, and it would let it run a little richer, because when it's running richer it's running a little bit cooler. Now that's not going to save one that's seriously overheating, but it'll help it run a little cooler. All kinds of strategies like that. Something else I always liked to do was take the either the scan tool, or on the older ones that didn't have data stream, I would check the like on a front wheel drive car, like a Taurus or something, I would back probe the engine coolant temperature sensor and watch the ECT voltage, and when it dropped below 450 millivolts the fan would kick on, and when it warmed back up to like 480 millivolts the fan would kick off. And that way I could actually watch it, and if I suspected a problem with the fan, I would watch that. That was before I learned, taught myself to go through spin the fan through and look for open commutators. But I could tell if the fan was working right or not, if the engine controller was turning it on or not, by watching that voltage while the engine warmed up. Well, you get a potentiometer and hook up to this thing, have it running in the condition where the fan ought to come on, and even with the engine stone cold, you can use your potentiometer hooked between the signal return and the ECD signal, watching your scan tool, dial the temperature to the point where the fan ought to come on, see if the engine controller will turn it on. There's all kinds of things you can do. But this is the opposite end of that. They don't want the evaporator turning into a block of ice, so if it's too cold outside, the ambient air temperature sensor, the controller's is programmed not to use the AC compressor when it's going to freeze the evaporator. If the high side service port is significantly hotter to the touch than the low side port, it indicates A, normal operation, B, compressor starting to fail, C, a thermal expansion valve stuck in the open position, or D, air contamination in the lines. Alright, if the high side service port is hotter, that's the way it's supposed to be. Systems operate normally. If you ever get in there feeling those things. Last week we were talking about, I think maybe the first test I did, test number 1, I had noticed that, when they first started putting together these R1234 systems, they were jumped all over the prospect of using a heat exchanger, running this line really close to the suction line, so that it would, so this cold air going on its way back to the back to the compressor would cool the refrigerant as it was on the way here. So the refrigerant's flowing in the opposite direction. And there was 2 or 3 guys that told me, they said, well, they were using this on R134 systems, before they went R1234. I never ran into that, but it makes sense to me, and I was wondering, why didn't somebody come up with this idea a long time ago? Because even on an R12 system, this would have been a good idea, and it's surprising to me that nobody ever came up with that. There's a really sharp guy that I know that's been teaching and works for a company that makes automotive training aids. And whenever R1234 first came out, I had a schematic that I had found somewhere that showed a heat exchanger like that in the system. And I sent that to him. I mentioned it having a heat exchanger, and he said, I've never seen that even on a 1234 system. And I said, well, I've got a diagram that I found somewhere that shows one. So I sent it to him, and he was kind of surprised. That's a sort of a one-off. Even 1234 systems don't typically use that. I don't know that it makes all that much difference, but it sure seems to me like a great idea. And if those lines are running right next to each other, you could probably build you a box around there, and get those lines to touch each other. You'd have to do it so they wouldn't rub a hole in each other, and that's just a good idea, because heat's always going to travel. It doesn't really matter if this gets warmer on the way to the compressor or not. If that liquid line is running close to the suction line, it's really a great idea. And so kudos to the people that corrected me on that. I wasn't aware at the time that some R134 systems had that heat exchanger, where they ran these 2 lines next to each other. So thanks for letting me know about that. Question 7, an intermittent shudder felt only when the AC is turned on, and is most likely points to A, a warped compressor clutch, B, a bad bearing or oil slugging, C, an out of balance blower cage, or D, a badly clogged cabin air filter. Well, let's talk about that for a minute. If it's only when the AC is turned on, it's most likely a bad bearing or oil slugging. I took his video in the shop when he came in with the compressor clutch smoking. I thought that was cool. But vibration only when the compressor cycle's on suggests mechanical stress, failing bearing, liquid refrigerant into the compressor, something like that. And I told you about Ford's compressor anti-slugging strategy on compressors mounted low. And when you're starting it up for the first time, it will energize the compressor clutch while you're spinning the engine to work any oil out of there so it doesn't slug the compressor. But an out of balance blower cage would only happen if you had the blower on, but the AC wasn't cycled on. And my buddy Alan Cobb came over there to the shop one day on his '98 Toyota Camry, And he goes, this thing's vibrating really bad. And he was a clean guy. Him and his wife both, their cars was always so clean. There was nothing, no papers laying on the floor. There was no dust anywhere. They kept their cars super clean. And I said, well, my goodness, the blower's out of balance, And so, because you could turn it on and it would just shake the dash whenever the blower, especially was on high. And so I said, let's get under there and pull the blower out. So we reached under there. It's usually pretty easy, pop the blower out there. And there was a bunch of, how if you took a dish towel and you put bleach on it and then you ran it through the washer, and how the bleach would turn that dish towel into nothing but strings and pieces of rag and all. There was a bunch of that stuff in the blower cage. And to this very day, he doesn't have any idea how that got there, and I can't figure it out either, to begin with, how it got to where it was in such bad shape. And because, I mean, the reason that reminded me of that is one time when I was, I don't know, probably 13 years old, I got in a fire ant bed. And so I says, oh, goodness, I got to do something about this. And so I had bees that stung me and all. I had, welts. So I got some a wash towel, brand new washcloth, soaked it in bleach, and just wiped my legs down with it where all of the ant bites were. And then I just threw it in the dirty clothes. And I happened to be there when my mother was taking the clothes out of the dryer, and that wash rag was coming all to pieces. But then she said, I wonder what happened here. Well, I didn't tell her what I had done. Anyway, the whole deal is we got that stuff out of there and cleared up the blower. But I asked him, I says, has your wife laid any rags up on the dash or anything? He says, no, she never puts anything on the dash. And so to this day, it's a mystery where all those strings and rags and even the stuff that was in the fan looked clean. Just really strange. Every now and then you'll run into a problem like that that seems like it would be easy to figure out, but we will never know where all that stuff came from. Question 8, what does the dual pressure switch handle when equipped? It's a ganged switch for AC and fan, automatically changes blower speed, ambient, cabin, and engine temperature. It measures refrigerant oil mixing. In other words, I meant to put it measures this. But what it does here, and this right here would be like on some of your Jeeps, you got your high pressure switch and low pressure switch. So this one here is going to turn off the compressor. See, when the AC's it's got an AC switch, says you got request, and then you got activation, and so it's going to have, you turn the AC on, you're going to get this, but you're also going to get this other input. And so if either one of these opens up, it turns off the compressor. But this one here is ganged, which means both of these click together, and so this switch sends a signal to request that the engine controller turn on the radiator fan. Now there's various different configurations of this. They're not all exactly the same. Just about every newer system out there now, the engine controller or the HVAC will has a transducer actually measuring pressures in the AC system, and that's just the way that is. Now there was that back in a long time ago, back in the 80s. Asian cars started coming out with what they call an AC amplifier, which was a little electronic box under the dash, and it was sort of like a little controller that decided based on evaporator temperature and other things when to run the compressor and all that. And it was connected to your control head, but it was taking input from other places and all that. And those systems were always, seemed to me to be unnecessarily complicated when you could just put a low pressure cycling switch in an orifice to. But those expansion valve systems are typically different and all that kind of thing. Question 9, which tool should be used to diagnose a pulse width modulated control cooling fan? Would you use a digital true RMS multimeter, a frequency genuating simulator, either analog or digital oscilloscope, or a high impedance 12 volt test light? Analog or digital oscilloscope. Multimeters only provide an average voltage reading. You can see this high impedance test light with the LED and watch the LED flash and all that, but the best way to do this is look at that. And if you understand duty cycle, when it's on 20% of the time and off 80% of the time, the blade will look like this. If it's on and off an equal amount of time, actually this would be on and this would be off, because you're reading the 12 volts coming through there typically in most cases. But and then 80% duty cycles whenever you know, it's on. So see, these right here, I could have inverted those. It's not always going to be the same if you're looking at the ground or the voltage, you know, feeding the component or whatever. You're going to have to know what you're looking at when you plug it in there. But anyway, I got a MixSig, one of those $800 oscilloscopes that I like to play around with, and I've also got a little one that I bought. You can get a little one trace oscilloscope off Amazon for not much money to play around with, if you want to just piddle with stuff in your garage, or just want something to check real quick. They got this U-scope thing you can connect to your wrist if you want to. You know, that's a pretty interesting thing too. You know, hook your leads up while you can look at the screen. It's right there on your wrist like a watch and all. Okay, question 10. A stuck closed thermal expansion valve will typically result in which readings or conditions? Low side, high side, high low side, low high side, low low side, short cycling magnetic clutch, no airflow, or iced up evaporator. Alright, this one here, watch this video I created right here. This is basically showing you, if you'll watch this little thing over here, when it closes up, no refrigerant can go through the evaporator. That keeps the evaporator from icing up. When this line is cold, that diaphragm is going to pull that thing closed. It doesn't have much of a orifice there. Now, some of your Volkswagens, and you're going to have low readings on both sides, incidentally, right here. We've talked about this before. But some of the Volkswagens I worked on when I was at the Volkswagen dealership in 1983, they had a screen in one of the lines going to this thing. It seemed like it was in the liquid line. And that screen would clog up with stuff. Of course, you know, typically that stuff's coming out of the desiccant bags in the receiver dryer. And we'd have to get up in there and clean those screens out. You could take the line loose from this thing and see all that. You'd have to pump out the refrigerant first. But anyway, you see all that clogged up screen. But most of them don't have a screen in there. But I was telling you about this Ford Edge. It was a 2012 model Ford Edge that one of my fellow instructors had. That she said after 30 minutes the AC would just quit cooling. And I says, well, you know, take it by the Ford place over there, because I figured they'd give it to the guy that I trained that was over there, but they gave it to some second string guy that didn't know what he was talking about. And he says, oh, we're going to have to replace this whole plenum up under the dash because the actuators aren't talking to the module or not. That was the dumbest thing I ever heard anybody say. $1,500, they wanted the charger to replace the whole plenum with all of its actuators. So I said, just, you know, pay them the diagnostic fee and drive it back over here. So she was 30 miles away. So she came back, hooked the AC gauges up, watched his readings, and it was cooling to start with. And then as the cooling faded away, both sides went low. And I said, well, she's got a bad expansion valve. And it took 30 minutes for her to do this, which is unusual because usually it's just right all the time. So her expansion valve was operating not right. So I took we got a $16 expansion valve. You know, I was at the college, we didn't charge labor, and she was just another instructor at the college. And we were had that $16 expansion valve on there. You know, recovered the refrigerant, put the expansion valve on there, put the proper charge back in it, and that took care of that. No problem. One of the things you got to be careful about in that same Ford place, whenever this lady had this, she had a Taurus, and she said that her refrigerant would leak out over about 2 weeks, and she would go by and they would recharge it at the Ford place. And then she would, and typically you pull the refrigerant out with a machine, you put the proper charge back in, right? And that's how you do it the right way. You don't want to vent the refrigerant to the atmosphere or anything like that, even though it is venting when it leaks. But so they couldn't find her leak, because it's hard to find a very small AC leak. You use dye and be really careful. If it's leaking in the evaporator area, you know, you're not going to see it unless it drips on the ground from the evaporator drain. So she, one of the things that I thought was funny there was she came over there. I say it was funny. Her compressor eventually locked up, because when you pull the refrigerant out with the machine, you also pull out a little bit of oil. And they had done this enough to where they had depleted all the oil in the system, and her compressor seized up. And so we basically had to replace her compressor, flush the system, and all that kind of stuff. We got her going again. Well, we've been here 30 minutes, and I've told you guys some stories, and I hope this was worth your time. And once again, if you got any comments, you know, correct me if I'm wrong about anything, and I always appreciate the feedback, and we'll see you guys next week.